All right, we're going to go ahead and get started talking about chemical reactions today. And this is going to be sort of an intro lesson that we're going to use to get into it. Now, our learning goal is going to be to learn and understand the basic properties of a chemical reaction. What does that mean? We want to look and see how do we know that a chemical change or chemical reaction has taken place? What are some of the symbols that we'll need to be aware of, and how can we use these to continue on? So, let's get right into it. Now, our first evidence of a chemical change is going to be that we have heat or energy released. If we're looking at the examples given to us here, we see the woman holding the flask, and there's this bright light being emitted from it, or showing from it, as well as the other looks like a small furnace, and we have this fire that's being released from it. Both of these situations are those that will let us know that, hey, we have something happening here. We have a chemical reaction taking place. Our second example is color change. Now, we don't want to say color change in terms of, just a slight change in the color. What do I mean? If I mix two things that have around the same color, or one is drastically different, and the solution just turns the color of the drastically different solution, as in the examples here, then I didn't really have a color change. But we want to look at, one, what happens over time. If I have a solid, does it change from its original state in color? But if I have a liquid and I mix them, I should come up with something that is very different and easy to tell that a change has taken place. An example given here on the screen with the Statue of Liberty. Many people don't realize, but the Statue of Liberty is originally made of copper. Copper, after it's been oxidized, begins to show off a greenish color. And so this is evidence that over a long period of time, we have had this chemical reaction that has taken place. Now, next thing that we look for is there an odor or some sort of gas that has been formed? Many times you may not catch it as a smell. Some situations you won't be able to because you may need to do the reaction in a fume hood. But if you see that there is smoke being formed, or that there is gas being formed, or bubbles forming, this will let us know another thing that a chemical reaction is taking place. Our last main one that we're going to look at is evidence of a precipitate. Now, when we talk about a precipitate, we're not talking about the things that fall from the sky. We're not talking about rain or snow. We're talking about a solid that forms at the bottom when you mix two liquids. This is going to be actually something that we look at a lot when we come to double replacement reactions. You may mix two liquids together and come out with something that is solid. Depending on the color of that solid, you can tell what are the species that are interacting. Now, how are we going to show these chemical reactions? Now, when we organize our chemical equation, we always want to remember that our reactants will be on the left side. Every single time. They'll be on the left side. If there's one reactant, 2 or 4, they will always be to the left. Whereas now, if we're dealing with our products are always, always, always to the right. Now, this seems like it's very simple, but I've seen many people make small mistakes, and I don't want you to lose out on those points. Now, the key thing, and I think this is self-explanatory, when we look at a chemical reaction, the products must be different than the reactants. If all I did is mix the two things together and they remain the same, there was no change. It was just a physical change. Maybe it's dissolved into the solution. But once I get a new product, a new something formed, this lets me know that I have indeed had a chemical reaction take place. Now, a chemical equation, in our minds, we want to think of it as a recipe. I'm taking these two chemicals and mixing them together to make a certain product. In the same way as when I go into the kitchen to cook, I may look and see what are the different things that I have. What are the different foods? And say I pull out some chicken breasts and some spaghetti sauce and some pasta. Well, I'm starting to form an idea of what's going to be my product. Now, in mixing them up, I can't just go into the kitchen and just begin to throw things together and say it will come out the way that I want it. I actually have to take some time and measure accordingly to make sure I get the taste that I'm wanting. So, in the same way, we have to do this with our chemical reactions. We have to make sure we have the correct amount. In the situation here, Again, iron plus oxygen, it doesn't always happen right away, but over time you begin to see that iron oxide is being formed. This is what we're going to continue to look at through this unit and our coming units. Now, here's just a list of symbols that you want to be familiar with. Go ahead and take a moment, pause, and make sure you write these down so that you know what they are when you see them on your worksheets. Now, this concludes our unit or our lesson for today. Go ahead and make sure you listen to the next part, where we'll go into the types of reactions and what are the ways that we'll be able to identify them and even to describe them in sentence form. Thanks again and have a great evening.